Oh, hello again. Today we're going to solve question 18, paper 1, QCAA External Assessment 2023. Okay, this question is, we know miniature Ferris wheel. So the wheel is the 6 meters in diameter. So that means the radius is 3 meters. So R is 3. The bottom carriage is 1 meters above the ground. When top of speed is reached, it takes 3 seconds from a carriage to travel from lowest to the highest. So give us the time taking from lowest to highest in 3 seconds. So we have a claim to be verified. So what is a claim? Is a vertical motion of the Ferris wheel produce the maximum vertical acceleration, excuse me, on each rider that is more than half the acceleration of the free fall. So we know the free fall means gravity. So gravity, which is free fall, what is a free fall? The free fall occurs when the gravity is only force acting on the carriage. So resulting is acceleration is 9.8 meters per square second. So now question is, we need to evaluate that claim is reasonable or not. All right, let's analyzing this question. So we got a motion is periodical because it's a repeated motion, up and down, up and down. So we're using the trigonometry periodical function. So I'm going to using start from, let's say from lowest, which is ground, then go up to the top, then come back to the low again. So it's a periodical function. I'm going to use in sine. So I said let the motion of the wheel be this. So we don't know so we call h is, which is the height of the wheel, height, the position, and t is the time taken. So the ht, which is the height, position of the wheel in relation to time. So we got A, B, C, D to decide, to determine. So we know pretty easy to decide what A is. So A is the amplitude, which is the 3 meters on the wheel. So when you go to top of the wheel, you'll be 3 meters above the, so total, so the halfway above that is 3 meters. So TA is a 3. Now, time taken for one cycle, which is so from lower to high, then come back to the low again, take 6 seconds. So because 3 plus 3. So therefore, I can work out a B. So we're using period function equal to 6. So the B is pi over 3. Now what's a C? C, because of no horizontal shift, so we call C is 0. However, D is the radius of the wheel, which is 3 meters, plus 1 meter above the ground. So that's why we call D is 4. So therefore, I've got an equation now, work it out. So HT is, so that's my function. 3 sine pi over 3t plus 4. Okay, now we're going to do, so we're going to do the claim. Now, when you work out acceleration, we need a velocity first. So we look at velocity. Velocity is a first derivative of h. So we do h dash. So when you do sine, derivative sine is cosine, then you put a pi over 3 because that's the the coefficient of that. So they end up with pi cosine pi over 3t. Then we do acceleration. Acceleration is derivative of the velocity. So when you do cosine, derivative of cosine is a negative sign, which is negative pi times by pi over 3. So it'll be negative pi over 3. Actually, you've got a square there. So now we need a maximum acceleration. So how to get a maximum? Because we know sine, the maximum value is 1. Doesn't matter what angle is. So, but we want to be acceleration to be maximum. So we need the acceleration to be, it can't be negative because we want to be maximum. So we absolute value of the front number, because that's the maximum is 1. All right, so we make a maximum of the acceleration. We will put absolute value on it. So the answer is pi square over 3. Now, because we can't use the calculator, so we estimate, let's say pi approximately equal to 3. So 3 squared divided by 3 is 3 minutes per square second. Now let's compare to half of the free fall acceleration, which is half of a 9.4, sorry, 9.8, apology. Then divided by 2, which is 4.9. So that's greater than the 3. All right, so that means the claim is half of that free fall is not reasonable. So conclusion is the claim is not reasonable. Okay, that's all we have got for this question 18. So I would just say this is a complex familiar because we need to find out those A, B, C, D. All right, so hopefully you will enjoy the solution and give us thumbs up if you do. And also don't forget to subscribe channel. I'll see you next time. Thank you. Bye-bye.